Hello friends, now we discuss third case of linear differential equation with constant coefficient. If the roots of the auxiliary equation are imaginary, if some roots of the auxiliary equations are imaginary, then they must occur in pairs. You know that the imaginary roots always occurs in pair. If some roots of the auxiliary equation are imaginary, then they must occur in pair, as imaginary roots always occurs in pair. You know that imaginary roots always occurs in pairs. Therefore, if some roots of the auxiliary equation are imaginary, then they must occur in pair. Let alpha plus I beta and alpha minus I beta be the imaginary roots of auxiliary equation, then solution corresponding to these roots will be, let us suppose that alpha plus I beta and alpha minus I beta, these are the imaginary roots of the auxiliary equation. Then the general solution corresponding to these roots alpha plus I beta and alpha minus I beta can be written as y equal to c1 times e to the power alpha plus I beta multiplied by x plus c2 e to the power alpha minus I beta times x. You know that this is the third case. If some roots of the auxiliary equation are imaginary, then they must occur in pair, because we know that imaginary roots always occurs in pair. Let us suppose that alpha plus I beta and alpha minus I beta, these are the imaginary roots of the auxiliary equation. Then corresponding to these imaginary roots, the general solution of the nth order linear differential equation with constant coefficient can be written as y equal to c1 times e to the power alpha plus I beta x plus c2 times e to the power alpha minus I beta x. Now this can be also written as c1 e to the power alpha x multiplied by c1 multiplied by e to the power I beta x. Similarly, here we can write e to the power alpha x multiplied by e to the power minus I beta x. c1, you can see here e to the power alpha x is common here. So in bracket we get c1 e to the power I beta x plus c2 e to the power minus I beta x. Here we break this power of e, that is alpha plus I beta x, can be written as e to the power alpha x multiplied by e to the power I beta x. Similarly, here we write e to the power alpha x multiplied by e to the power minus I beta x. You can see here e to the power alpha x is common here, so we get c1 e to the power I beta x plus c2 e to the power minus I beta x in bracket. You know that this e to the power I beta x can be written as cos beta x plus I sin beta x. Similarly, e to the power minus I beta x can be written as cos beta x minus I sin beta x. Now, e to the power alpha x, here you can see this cos beta x is common. So, c1 plus c2 in bracket and cos beta x. Similarly, here we take common I. So, c1 minus c2 sin beta x also common here. Now we put c1 plus c2, this is equal to c dash, and C1 minus C2, this is C double dash. So here C dash cos beta x plus I times C double dash sin beta x. You know here this I times I C double dash sin beta x. Here this is C double dash sin beta x. So here we put C1 plus C2 is equal to C dash and I times C1 minus C2 is equal to C double dash. Where C1 plus C2 is equal to C dash and I times C1 minus C2, this is equal to another constant C double dash. Now you can see this can be also written as y equal to e to the power alpha x C1 cos beta x plus C2 sin beta x. Now again we put here C1, this is equal to a cos alpha and C2 is equal to minus a sin. Here C1 is equal to a cos b and C2 is equal to minus times a sin b. Here we put C1 is equal to a cos b and C2 equal to minus times a sin b. So this can be also written as e to the power alpha x a cos b cos beta x minus a sin b sin beta x. Now taking common here a, so we get a times e to the power alpha x cos beta x cos b minus sin beta x sin b. Here cos a cos b minus sin a sin b, this is equal to cos a plus b. So this can be written as y is equal to a e to the power alpha x cos b plus cos beta x plus b. So this is the general solution of the given differential equation. Now you can see here we write this is C dash, this is C dash and this is C double dash, this is C dash and this is C double dash. Now you can write the general solution of the auxiliary equation if the roots are imaginary. If the roots of the auxiliary equation are alpha plus I beta and alpha minus I beta, then the general solution can be written as either 1 or 2nd. If the roots of auxiliary equation are imaginary, then general solution of the nth order linear differential equation can be written as either 1 or 2. Now we take one example here. Now we solve this example. d2y by dx2 plus 4y equal to 0, y equal to 2 and dy by dx equal to 0 when x equal to 0. You can see here this is the second order linear differential equation with constant coefficient. So this can be written as d2y plus 4y equal to 0. Now this can be also written as d2 plus 4y equal to 0. Here capital D is equal to d by dx, you know. Now we find the auxiliary equation. You know auxiliary equation, if we replace m in place of capital D, we get the auxiliary equation. So this is m square plus 4 equal to 0. Now we find the solution of this quadratic equation. So m is equal to m square is equal to minus 4. So we get m is equal to plus minus under root minus 4. So we get m is equal to plus minus 2i. Because the square root of 4 is 2 here. and square under root of -1 is equal to I. This is iota. So here we get the roots of the auxiliary equation are 0 plus minus 2i. So alpha plus minus I beta, we compare it. So alpha is 0 here and beta is 2. You can see here the roots of this auxiliary equation are imaginary. So this is the third case. Here the roots of auxiliary equation are imaginary. This is in the form of alpha plus minus I beta, where alpha is equal to 0 and beta is equal to 2. So the general solution of the given differential equation of the given second order linear differential equation with constant coefficient, general solution of the given differential equation is y equal to c1 cos, y is equal to e to the power alpha x c1 cos beta x plus c2 sin beta x. Here you know that alpha is equal to 0, so this becomes y is equal to e to the power 0x, c1 cos beta is 2 here, so this is c1 cos 2x plus c2 sin 2x. You know that if the roots of the auxiliary equation are imaginary and that are alpha plus I beta and alpha minus I beta, then general solution of the differential equation can be written as y is equal to e to the power alpha x c1 cos beta x plus c2 sin beta x. Here you know that alpha is 0 and beta is 2. Put alpha is equal to 0 and plus of beta we put here 2. So e to the power 0, this is 1. So the solution is, general solution is y is equal to c1 cos 2x plus c2 sin 2x. Now we put boundary condition. So suppose this is 1. Now we differentiate this 1 with respect to x. We get c1 is constant here and differentiation of cos 2x is minus 2 times sin 2x. And c2 is constant here and differentiation of sin 2x is 2 cos 2x. Suppose this is second. Now we put y equal to 2 and x equal to 0 in 1. So in place of y we put here 2, in place of x we put here 0, so cos 0 is 1 and sin 0 is 0. So we get here c1 is equal to 2. Similarly, we put dy by dx equal to 0 in second and x equal to 0 in the right in equation second, we get minus 2c1 and sin 0 0 plus 2c2 and cos 0 1. This gives 2c2 is equal to 0, this gives c2 is equal to 0. So here we get c1 is equal to 2 and c2 is equal to 0. So the particular solution of the above linear differential equation with constant coefficient is, here we put value of c1 and c2. c1 is 2 here and c2 is 0. So the solution is 2 cos 2x. So you can see here the roots of the auxiliary equation are imaginary. So how can we find the solution of the linear differential equation with constant coefficient? We take another second example. Here you can see this is the third order linear differential equation with constant coefficient. So for solving this, first we write as d cube y minus 8y is equal to 0. Now taking common y, so we get here d cube minus 8 times y equal to 0. Now we form auxiliary equation. For forming auxiliary equation, replace capital D by m, so we get here m cube minus 8 equal to 0. So this is m cube and 8 can be written as 2 cube. Using here a cube minus b cube, we get m minus 2 in first bracket, and the second bracket we get m square plus 4 plus 2m. Using a formula of a cube minus b cube is equal to a minus b in first bracket, and the second bracket a square plus b square plus ab. Now we solving this m minus 2 equal to 0, we get one root of the auxiliary equation is 2. And if we take m square plus 4 plus 2m is equal to 0, so this is the quadratic equation in m. Now we solving this quadratic equation by Sri-Gachar formula and get the value of m. So m is equal to minus b, so this is 2 plus minus under root b square. So 2 square is 4 minus 4 ac, so this is 16 divided by 2. Now this can be written as minus 2 plus minus 4 minus 16, this is minus 12, and minus 12 can be written as 2 root 3 I divided by 2. Now taking common 2 and cancel out, so we get m is equal to minus 1 plus minus I root 3. Here the roots of the auxiliary equation are 2 and minus 1 plus minus I root 3. You can see that one root is real and other two roots are imaginary. So here one root is real. So the general solution of this third order linear differential equation with constant coefficient. So the general solution of one is y is equal to c1 times e to the power 2x. You know that here y is equal to c1 times e to the power 2x, and here we can see this is alpha plus minus I beta. So this is here alpha is minus 1 and beta is root 3. So the other two roots are imaginary. So we can write here e to the power alpha x. Alpha is alpha x and c2 cos beta x plus c3 sin beta x. So y is equal to c1 times e to the power 2x plus e to the power minus alpha x. Alpha, in place of alpha we put here minus 1, and c2 cos beta, beta is root 3, so this becomes x root 3 plus c3 sin x root 3. So this is the general solution of the given third order linear differential equation with constant coefficient. Here one root is real and other two roots are imaginary. Now we take another example, third. Now we take third example, that is d4y by dx power 4 plus d2y by dx2 plus y equal to 0. You can see here this is the fourth order linear differential equation with constant coefficient. So for finding solution of this linear differential equation, first we write here d2y, d4y plus d square y plus y equal to 0. Taking common y here, so we get d to the power 4 plus d square plus 1 y equal to 0. Now we finding auxiliary equation. So for auxiliary equation we replace d by m. We get m to the power 4 plus m square plus 1 equal to 0. You can see that this is a 4-degree equation. This is the biquadratic equation. So we find here 4 roots of this auxiliary equation. So for finding roots of this auxiliary equation, first we make perfect square here. So m to the power 4 can be written as m square whole square, and 1 can be written as 1 square, and we add here 2 times of m square multiplied by 1, we get 2m square, and subtract 2m square also, and this m square is here this. So for making perfect square, first we write here m to the power 4 as m square whole square, and this one is also whole square. Now we multiply m square by 1, we get m square, and we get 2 times of m square, that is 2m square, adding 2m square and subtracting 2m square, we make this perfect square. Now taking these first three terms, so you can see this is square of m square plus 1. M square whole square plus 1 square plus 2 times of m square and 1. Now this minus 2m square plus m square, this is minus m square. Now using a formula a square minus b square, we get a plus b in one bracket. So we write here m square plus 1 plus m. In the second bracket a minus b. So this is m square plus 1 minus m is equal to 0. Now we taking m square plus m plus 1 is equal to 0 or m square minus m plus 1 is equal to 0. Here this is the quadratic equation, this is also the quadratic equation. We get 2 roots from this equation and 2 roots from this equation. So solving this by Sridharacharya formula and get the roots of this above equation, auxiliary equation. So this is minus 1 plus minus under root b square, this is 1 minus 4ac, this is minus 4 upon 2. Similarly here we find m is equal to 1 plus minus under root b square is 1 minus 4ac upon 2a. So this will be m is equal to minus 1 plus minus, here this is minus 3. So this can be written as I root 3 divided by 2 and here we also write I root 3 divided by 2. This can be also written as m is equal to minus 1 by 2 plus minus I root 3 by 2. Here also we write 1 by 2 plus minus I root 3 by 2. So you can see here the roots of the auxiliary equation are, there are 4 roots of the auxiliary equation and all roots are imaginary. So we can write the solution of this general solution of given differential equation is y is equal to e to the power alpha x is minus 1 by 2, so this is minus x by 2, and c1 cos beta is here root 3 by 2, so this is x root 3 by 2 plus c2 sin x root 3 by 2 plus e to the power alpha x, this is alpha is here 1 by 2, so this is x by 2, and c3 cos beta x, beta is root 3 by 2, so this is x root 3 by 2 plus c4 sin x root 3 by 2. Here you can see that this is the general solution of the given fourth order linear differential equation with constant coefficient. First we form the auxiliary equation and finding the roots of the auxiliary equation. Here 4 roots of the auxiliary equation and all the roots are imaginary. So the general solution can be written as y is equal to e to the power alpha x in bracket c1 cos beta x plus c2 sin beta x. Thank you.